Hi, students. How are you today? I thought that I would spend a little bit of time going over the test that you had and some of the thinking that went behind getting some of the answers, those kinds of things. So let's get started. The test had 35 items plus a bonus. A couple of you did see that this actually reduces to -3, and -3 is an integer, so that would be D. The square root of 50, if you were to plug it into a calculator, which you were allowed to do, you would see it just goes on and on and on with no repeating decimals. That is an irrational number, A. Okay, the set below contains only what type of numbers? All of those numbers are rational numbers, B. Now, we had to do a little bit of evaluation to get the answer to this. The square root of -2 minus the square root of 2. When you see something like this, students, don't rack your brains out trying to evaluate the square root of 2. If you're taking something away from itself, it's always 0. And 0 is a real number. It's a rational number. It's an integer, and it's a whole number. So which of the following is true regarding number sets? Are all integers whole numbers? No, because we could have negative integers. Let's look at C. All real numbers are integers? No, because we could have rational numbers, fractions, decimals, and those are not integers. All rational numbers are natural numbers? Not necessarily true, but all irrational numbers are real numbers. So the answer there is B. And again, you could have used that chart that I gave you to help you out with that. So which property justifies the statement below? That's the distributive property. We multiplied x times y to get xy, and we multiplied -3 times -3 times x to get -3x. So x times y, let me go over that again. I think I wasn't clear. All right, let's take 2 on that. So we multiply x times y to get xy. And now I'm going to change the color. And we're going to multiply x times -3 to get -3x. That's the distributive property C. Okay, let's go down. Which property justifies the statement below? We have a plus b equals a plus b plus 0 equals a plus b, and that's an identity. That is B. Which property justifies the statement below? If 9x equals 27, then 27 equals 9x. That is the symmetric property. Thing equals itself. So an example of the reflexive property could be 65y equals 65y. That's the reflexive property. The associative property, okay, let's see. Let's do 7 plus 2, and we'll make that a quantity, plus 5 equals, now we'll have our 7 plus, and then we'll have the quantity of 2 plus 5. The associative property works for multiplication and addition only. There is no associative property for division or for subtraction. I saw some of you put subtraction. So integers are not closed under which operation? In other words, an integer added to an integer, will that always give an integer? An integer subtracted from an integer, will that always give an integer? An integer times an integer, will that always give an integer? Yes, all those 3 cases are a yes. But when you divide an integer by an integer, for example, if you divide 2 by 3, you are not going to have an integer, right? You're going to have 0.66, a repeating decimal. So the only operation in which integers are not closed, where they can produce something other than an integer, is division. Which of the following is a false statement? So it turns out it's the first one. Natural numbers are not closed under division, similar to what I just showed right here in number 11. So the answer there is A. Natural numbers are not closed under addition. Okay, let's simplify this expression. So we'll start with the exponent. So we have 4 plus 2 times 2 times 2 is 8, minus the absolute value of -4 is 4. We can just work directly from left to right. 12 minus 4 and 12 minus 4 equals 8. Start from the inside out here. But we can also work with this exponent here. So 3 times 3 is 9, minus 3 times, okay, let's put our parenthesis, 5 times 5 is 25, minus 9, that's closed in parentheses, divided by 2. And let's close our bracket. Okay, now we have 9 minus 3. We have our open bracket. Now we evaluate 25 minus 9, which is 16. That eventually will be divided by 2. Close the bracket. Now we're going to work inside the brackets. 9 minus 3 times 16 divided by 2, which is 8. Now multiplication and division before addition and subtraction. So it would be -3 times 8, which is -24. And 9 minus 24 is -15. Let's do another one. So we'll start. We've got some, let's start within the parentheses. So 3 minus 13 is -10. And that quantity will be squared, plus 14. And fraction bar, 4 squared is 16. Now we can go ahead and do that 5 times 2, which is 10. 16 minus 10. Okay, so now we have 100. Because -10, I'll write that up here, sidebar, -10 times -10 is positive 100. Negative times a negative is a positive. So 100 plus 14 over 16 minus 10, which is 6. I'll work over here. So we have 114 divided by 6. Now, very often in algebra class, we do leave improper fractions, but we don't leave them if they can be simplified to a whole number. 114 divided by 6 is 19. Okay, now we're evaluating by making a substitution. So A equals -8, B equals 17, and C equals 21. Okay, so we're going to have our A term squared minus our B term, will go in there, plus C. I always make parentheses when I substitute. And let's do our substitutions. So A is -8, and B is 17, and C is 21. Okay, let's work from left to right. So -8 times -8 is 64. That's our 8 squared, minus 17 plus 21 is 38. And 64 minus 38 is 26. Now, we've got evaluate the expression of x equals -1 and y equals 3. With these exponents especially, you want to be very, very careful. So 3x is -1, so I'm going to use parentheses, and then it's squared, minus y equals 3, and then that is also squared. Be very careful. So now we have -1 times -1 is 1. So we have 3 times 1 minus 3 times 3, or 3 squared, is 9. 3 times 1 is 3 minus 9. 3 minus 9 is -6. Now we're asked to evaluate an absolute value problem. So if A equals 8 and B equals -5. So here's our absolute value bars. And I'll change my color. So A equals 8. So we have the absolute value of 8 and minus the absolute value of -5. The absolute value of 8 is 8. Minus the absolute value of -5 is 5. Absolute value can never be negative because it represents distance from 0. So 8 minus 5 is 3. Okay, 1 less than twice a number. When you see twice a number, I want you to think grouping. So that's 2n. So 1 less means subtraction. So we need a 2n minus 1, which is D. It's not twice a number minus 1, that would be C. It's 1 less than twice a number. That's one of our turnaround phrases. 5 times the difference of a number and 3 is 17. So difference is division. And a number is going to be divided by 3. So we're going to have n divided by 3. That eliminates the first 2. So we have a quantity of a number and 3, and it's going to be multiplied by 5. We're not just multiplying the numerator, we're multiplying the entire quantity of a number and 3. So we have 5 times the number and 3 is 17. D. Okay, if a number is no more than 50, can it be 50? Yes, it can. Can it be 49? Yes. Can it be 51? No. So x must be less than or equal to 50. If your grade must be at least 64 to pass this class, can it be 64? Yes, at least 64, so 64 counts. Can it be 63? No. Can it be 65? Yes. So G, they're using G for grade. You can use any letter you want for these, but G for grade, G must be greater than or equal to 64, which is D. Let's go on to number 23. We're going to simplify an expression. We have 2m minus 16 plus 5m plus 45. First, we have positive 2m plus 5m, which is 7m. So we can already eliminate 2 answers right there. Negative 16 plus 45. Okay, ignore the signs, subtract the smaller number from the larger number in terms of absolute value. And that is going to give us 29. So that means A is the correct answer. So let's simplify 2x minus 4y plus 6 plus 3x minus 9y minus 4. So let's start with the x's. We have 2 plus 3 make 5, 5x. So we can eliminate this. So we know we're going to have 5x. Let's look at the y's. I have -9 and -4. So -4 minus 9 is -13. And then I have positive 6 minus 4 plus 2. That sure looks like A to me. Now we're going to simplify this expression completely. But the first thing we need to do is distribute the 4 to the 2x and to the positive 7. So 10 minus 4 times 2 is 8, so 8x. This is a negative 4. Negative 4 times positive 7 is negative 28. Students, this negative sign goes with the number behind it. So 10 minus 8x minus 28. So our next task is to combine 10 and negative 28. Well, 10 minus 28 is negative 18. So we're going to have negative 8x, which is what we have right here. And then when we combine the 10 and the negative 28, we have negative 18. We generally put the variable term first and the constant separate. A couple of you wrote negative 18 minus 8x. You just didn't know, but now from now on, I'm going to expect you to write it so that the variable is first. So negative 8x minus 18. Okay, we've got to distribute the 4 to the 5w and to the negative 3. So that's going to give us 4 times 5. That's going to be 20w. 4 times negative 3 minus 12. Now, when you have a negative sign outside of a parenthesis and it has to be distributed, that's like an invisible 1, and negative 1 times the quantity of w minus 1. The only effect it has is to change the signs of these things inside, these quantities inside. So the w right now is positive, the 1 is negative. So we're going to make the w negative and we're going to make the 1 positive. Now we can combine like terms. We have 20w minus 1w is 19w. And then we have minus 12 plus 1 minus 11. Number 27, this is a rectangle. That means that this side, the x plus 2 side, is the same length as this side. And the 3x minus 7 is the same as this side at the top. So we've got x plus 2 over here and 3x plus 7 here. Let's just count the x's. 3 and 3 more make 6. 1 here makes 7. 1 here makes 8. So we've got 8x. Now we have, oops, I made that a positive. That should be a negative. Sorry, let's fix that. I apologize, students. That should be a negative. So we have negative 7, negative 7, that's negative 14, plus 2, that's negative 12, plus 2 more, that's negative 10, for 8x minus 10. Color going here. Okay, a couple of things you could do here. But what I would do, the first thing I would do here is I would eliminate the constant. So we're going to subtract 7 from both sides. Now, they didn't ask us to solve this. They just wanted to know what the first step was. But I'm going to go ahead and solve it. Minus 4, negative 1 and negative 7 are negative 8. Now, our next step, I'm going to multiply both sides by negative 4 because the scales of algebra justice must always be balanced. This cancels. That gives us x equals positive 24 because positive 32 because negative times a negative is a positive. 8, 16, 24, 32. So x equals 32. But the question was, what's the first step? The first step was to subtract 7. Just wanted to solve it to give you a little extra learning there today. Now we're going to solve this equation. Let's subtract 1 from both sides to keep the scales of algebra justice in balance. And we bring down 5x. Positive 1 and negative 1 cancel. Negative 49 minus 1 is negative 50. Now we're going to divide both sides by 5. And this 5 over 5 cancels. And we have x equals, and what's negative 50 divided by 5? Negative 10. Hey, this one looks pretty similar, but we're starting out with subtraction, so we're going to add 5 to both sides to keep the scales of algebra justice in balance. Cancel negative 5 plus 5 makes 0, and bring down my 2/3 x equals 7. Now I can multiply by the reciprocal of 2/3, or I could multiply both sides by 3 and then divide by 2 at the end. I think I'm going to multiply everything by 2/3. So instead of having 2/3, I'll multiply by the reciprocal because the idea is to make this equal 1. So I'll do that here as well. Okay, so this all becomes 1. It all cancels itself out and goes away. And then I have x equals. Now I need to do 7 times 3/2. Remember I said sometimes you can make a sidebar? You could put 1 under there. So 7 times 3 is 21. 1 times 2 is 7, 14, 21 times 2. Oh, I forgot to make my 12 here. My bad. That's getting late in the day. I'm going to erase that. I'm going to erase this. I knew I made a little mistake there. Sorry, guys. Teachers make mistakes too. It gets late and we're tired. Okay, I don't think I want to use yellow. It won't show up. Okay, 7 and 5 make 12. I forgot to add the 12 times 3 over 2. Why, how I back to my pen mode. Okay, 3, 2. So I'm sorry. 12 over 1 times 3 over 2. And cancel that, cancel that. 6 times 3 is 18. 18 over 1 makes 18, so x equals 18. Sorry about that, I almost missed it. All right, last few problems. Solve the equation below. Save this 4a for later. The sign in front of here, invisible plus. That means we want to subtract 2. We're using the inverse. Color, here we go. Negative 2 and positive 2 cancel. Negative 4a equals 16. And now we need to divide everything by negative 4. It's not an inequality, it's just an equation, so we don't have to do any weird flipping or anything like that. Negative 4 over negative 4 cancels. It equals 1. A equals 16 divided by negative 4 is negative 4. Now, students, I had a couple people just wrote negative 4 in the box. No, when you do these problems, you need to put the letter x equals, A equals. Okay, so the next problem, first thing we want to do is subtract 12 from each side because this is a positive 12. So we'll subtract 12 from each side. This cancels, and we have negative 1 over 9n equals 17 minus 12 is 5. Now, just going to multiply both sides by negative 9 so that I can get rid of that denominator. So all of this cancels, and I'm left with 1n, or just n, equals negative 45. And that goes right there. Okay, getting near the end. Here's an inequality. First thing we'll do is add 1 to both sides. This cancels. 4x is less than or equal to negative 28. Negative 29 plus 1 is negative 28. Now we need to divide. We're not dividing by a negative number, so we don't have to worry about flipping the inequality sign. But we are going to divide by a positive 4, which gives us x is less than or equal to negative 7. In this problem, this is a problem where it would be best to get rid of the denominator first. If you have a variable and a constant in the numerator, let's get rid of that denominator. Whatever you do to one side of an equation or inequality, you do to the other side. So this will cancel, and that leaves us with x minus 13 is less than, oh, what do we need to do? Don't forget, we just multiplied by negative 6. We have to flip that inequality symbol. Did you remember to do it? X minus 13, now it's going to be greater than 6 times, negative 6 times 3 is negative 18. Now all we do is add 13 to both sides. And x is greater than negative 5. Negative 18 plus 13 is negative 5. Last two problems. Which graph represents the solution to the inequality below? Well, first you had to solve this. This is a positive 4, so let's subtract 4. Whatever we do to one side of an equation or inequality, we do to the other. Now we have negative 2x. We haven't done anything multiply or divided by a negative yet, so we don't have to flip this yet, is greater than negative 2 minus 4 is negative 6. Let's change our color. Now we're going to divide both sides by negative 2. Now here's where we have to use our rule. When we multiply or divide by a negative, we're going to flip the inequality sign. So that gives us x, flip the sign because we divided by a negative, is less than or equal to negative 6 divided by negative 2 is 3. And that's our final answer. X is less than 3. So this here, x is greater than negative 1. Here, x is less than negative 1. Here's our 3, and x is definitely less than 3. This is our answer, C. And the fourth one actually says that x is greater than, and that would be incorrect. Now, Bob would like to create a triangle that is 7 less than twice the perimeter of the triangle below. Give an expression for the perimeter of the new triangle in simplest terms. So 7 less than twice the perimeter. So we have to add this up double it, and subtract 7. So let's add up the y's. 4 and 2 make 6, and 1 more makes 7. 7y. 9 minus 1 is 8, so 7y plus 8. Now we have to take all of that and we have to multiply it by 2. I will use grouping symbols and the distributive property. 2 times 7y equals 14y. 2 times 8 is 16. Okay, so we did twice the perimeter. Now we have to do that 7 less. Minus 7, which leaves us with 14y plus 9. And that's the final answer. It was a little tricky, that one. So I hope you did well. If you didn't, I hope you know what to do in order to do better on the next test. Good luck and keep working hard.